Okay, good morning. Um, Today we will talk regarding again the compression technique. Something that I should say that some lecture we just suppose 10 minutes we were as we see the record. In some of the lectures, 10 minutes like that we finish the lectures faster. Even we had two more lectures in the time that officially we shouldn't have, but we had. What we plan from this week that we have the four full 90 minutes lecture, as well as we will have some extra lectures soon that I will tell you the date and time. Let me confirm with the school and your timetable. Be ready for that. And as I saw, this is the end, little bit at the end of chapter comparison. Uh, After that, we have morphology, and uh, I can say more than 90% of our syllabus is covered. Uh, in this way, if we have the time, then we may talk little bit about color image processing and object recognition, which is also that too is much more nice. Means that color image processing and object recognition. Rarely about object recognition people speak in the what we can say bachelor course, but it's good if we have time we can talk regarding it, have some example, see some form, and uh, have the knowledge about it. Mm. That is what we discussed with the school, and as some of you was eager to have more lectures time, then we planned yesterday for with the school to do that. It's good. I'm very happy that we have some persons that they want to learn more. As you know that all the time I'm wanted to have such this student. Thank you. Um, Let us continue about the image compression. I bring some videos and some uh, more example about them that we can help us to understand it. We have once more review the Huffman coding, but now we will see uh, from other aspect. We will talk about arithmetic or range coding, LZW coding or addresses in the interpixel redundancy, round left coding RLC, and bitplane coding. These are the subjects that uh, mostly in the first lecture of today I will cover. Let us see how much time we have. Then we will go for the next lecture. That is also about this compression method. And hopefully we should going to do the most of the part for this compression today. As we talk for the image and specifically for the lossless compression, we have with the view of image in the form of matrix, something like f, x, and y. We have some compression steps, and after that we have some decompression, which will lead to have the f prime f x y. And the other way, if we want to know the error between these two, the ideal thing is that we wanted that the compression and decompression will not affect the major data between these image after actioning. Means that suppose when you zip one file, you want when to unzip it, you have the less effect on the quality of the data or type of, not exactly type, the nature of maybe the data. Something that maybe even you see from your mobile phone. See, suppose when you want to send the image by WeChat, there is one option. One is that you will send the full form of your picture. Another one is that there is something that little bit it will compress it. If you do the compress, you will see that the image quality will maybe little bit reduce. And if you put the full form, you will see that the image quality is has the same as sender. Something like this will happen in this compression method. Once more, let us see what is the lossless coding technique. I mean, the entropy, or people call it entropy coding. We have these methods on them: repetitive sequence encoding, or RLE, something like RLE. We have some statistical encoding like Huffman, arithmetic, LZW coding. Lossless predictive coding, that we call it DPCM, and bit plan encoding, which we know it as one specific methods. Our today talk in the first lecture maybe will be about this graph, and we will going to see the difference and uh, feature and um, application somehow of these techniques one by one. First, we'll start from Huffman coding, or addresses coding redundancy, which is a variable length coding technique. It's something like this box, as you can see. In the box, you have some source, which by that, first you will convert to the grade level, and then you will encoding, and after that, compression can be achieved by encoding the AK appropriately, and then you can decode it if you want to unzip or something like a decompression. Source symbol are encoded at one time, and there are one-to-one corresponding between source symbol and code word. Optimal code is the minimized code word length per source symbol. This is the something that we are searching for, that we want to have some optimal coding. And by this method, you can do one of the doing the one of the redundancy coding method, which will help you to compromise. Let us see once more. I have done this example before with you, but today again I will describe it, and then I will add one more example which will help you to understanding better. If we want to know the process for the Huffman coding, we have two steps. One is, the first step is forward pass. What we will do in these steps: first we will sort the probabilities per symbol, and then combine the lowest two probabilities together. This job should do 2 by 2. Suppose for the data that I show you here, you will see that I have the symbol from A1 to A5. First of all, I sort my data based on the probability that I have. As suppose the uh, question tell me, or the problem tell me that the probability was zero point 0.4 for A2, zero point 0.3 for A6, zero point 0.1 for A1, again 0.1 for A4, point not 6 for A3, 0.4 for A5. And if we sort this data uh, from the up to down, okay, with the decrement mode, you will see that A3 and A5 has the least probability at the first step. Then these two can be add and answer should be 0, 1. Then we will go for round 1. In the round 1, again, if you sort the data, which is already sorted because last step with the probability you sorted, you will see that you have two again list data. Actually, you have three, but based on the model, you should select the last two one, means that last 2.1 you will select, add them together, and then put it one step ahead. Okay. If you do like that, then you will see that again we have last two is point 0.2 and point 0.1, which you will add them, it's become point 0.3. Again, next step, you have point 0.3 and point 0.3, which will be add and go one step ahead, point 0.6, and point 0.4 will be revealed. This step 2 means that combine the lowest two probabilities will repeat only two probabilities will be remain. Okay, this is the first step or first round of Huffman coding that we call it forward pass. But now to return back, we need to do the backward pass and assign the code symbols going back. What we will do, we know as the first one, as the higher probability, I mean the point 0.4 if you see, which was the higher probability that we had, we call it 1, and another one we call it 0. Then we will come back. When you come back, again you know that the higher one is zero point 0.4, which will have the remain value of 1. That zero point 0.3 will become 0 and 0. But from the last step, again that 0 will come to pictures and we will put it there. Okay. Again, we go for the next step. We have the 1, and then you will see that zero point 0.3 is 0, 0. We will put it there. But point 0, point 0, point 2, and point 1, again, they are list 1. We call it 0, 0. But from the last step, they have the value which is remain. Again, we will bring it. Means that 0, 1 will remain there, and 0 and 0, 1 will come again. Next step is again like that. Point 0.4 and point 0.3 will remain the value. And then uh, 0.10 will come for 0, 1, and then 0 and 1 will remain that we will add it together. Like this, we can code the data that we have based on the probability. Um, in this coding, then based on this data that you acquired, you should calculate some values and some parameters. One is that L average or LAVG, which is assuming the binary coding. And as we had 6 symbols, we need 3 bits of codes of A1, A2, A3, A4, A5, and A6. Okay. Then we, based on this formula of LAVG, we can have the accommodation of that, and you can calculate the 3-bit symbol. Then LAVG can be the key, as this formula of K1, accommodation of K equal to 1 to 6, and then you should multiply the value that you uh, calculate, means that 3, to each probability of which you have. It means that at the LAVG, you have the 2.2 bits per symbol at the end. This is one parameter that should calculate. And then uh, you should remember that both coding and decoding can be implemented with the help of the lookup table, and note that decoding can be unambiguously and you can see in the event table here. But I thought that even I teach you these, but I thought that maybe one and solution means that this problem that we solve, uh, it's even better. Can you hear the song now or no?
Your
No,
sound can
sir.
hear, but the video sound can't.
Okay, okay, okay. No problem. I will describe for you. Actually, I wanted to solve with hand with you, but I found that some better description they were available on the net, and as I should make the PPT fast for you for today, I wanted to add it. Then I bring their video. I think it's better than then I talk on that. See, suppose I have this example. What is that? I have four symbols S0, S1, S2, S3, and S4, which they have the probability of point 0.4, point 0.2, point 0.2, point 0.1, and point 0.1. Okay? Then what we want to do, we want to calculate and see the Huffman coding and the coding process based on. Oh, I should not play much more with this. Wow. Okay. I think it's hang again. Just 1 minute. The question is that how I should calculate the uh, Huffman coding for these mentioned data. Just please hold on. Some problem we had with PPT that it will come up again. It's become like this. I don't like this type of video monitoring. We should change the method. Okay, just 1 minute. Come up. Yes. Can you please see now?
Mm, yes, sir.
Okay, good, good.
No, sir.
It should not. It should come now. Can you now see?
Yes, sir.
Okay. As you see here, you have the probability of the data that you see. And what first step we had done? We sorted based on decreasing the data value. Means that from point 0.4, point 0.2, point 0.2, point 0.1, point 0.1. We sort the probability, and then we should write the symbols in front of them. Means that which probability related to the symbol. What we will do first, we will find the lowermost probability together. Point 0.1 and point 0.1, it's become point 0.2, then again point 0.2, point 0.2, and point 0.4. We will return them. Okay. Again, we have point 0.2 and point 0.2, which is the least probability. We can add them together at the point 0.2, point 0.2, and point 0.4. Then these two again are the least one. We'll go and one step again, point 0.6 and point 0.4 will remain there. Now, this is the first step that we had. Now we will go to assign some codes to to these probabilities calculation that we have. See, we will give the upper one as 0 and next one as 1, and then we again go to uh, calculate the, Yes. Yes. We will give the 0 and 1 to this probability and try to step back like that. First, see points 0 and 1. We will do it like this: 0, 1, 0, 1, 0, 1, 0, 1. Okay. But now we should come back and see that. Suppose from the back step related to point 6, we had these two numbers that 0 was the value. I will put the 0 here. Okay. Point 4 was 1 remain. I continue. Again, for the lowest one, 2 0 I had here. Again, I will add that 2 0 here. See, put 2 0, 0, and 1 0 will come up. 1 will again remain there. T02 is result of that probabilities. Again, I will add these two, and this point 2 will we share with others. See, 0 0, again 1 0, and then 1. This is the first step that we will assign the sum codes to our probability. Now we should calculate the length or L average, as we say. First is length. Length is has the formula of accommodation of I equal to 1 to n PIL. And now we are going to know that we had point 4, which should be multiplied by 1, point 2 multiplied by 2, point 3 multiplied by 3, point 4 multiplied by point 1 again multiplied by 4, and point 1 again multiplied by 4. Then the calculation for this become L equal to 2.2. And now we should calculate the entropy, a formula of H, which in that we have the DLI log or DI of the log of 1 divided by DI. DI is the probability, which is the maximum here is zero point 0.4, and we should calculate one by one. Just remember that we should calculate the log 2 of that. See, if we calculate this, the total value become 2.21. Remember that you should have the log 2 and do your calculation based on that. The next parameter is the eta, that it's the come out from h divided by li. We have the value for l, we have the value for h. We can calculate it simply like that, 0.96. You can see. Next is the redundancy, as we call it gamma. And by this gamma, we know that 1 minus eta will come, which we had the value of 1 minus 0.96. It's become 0.04. And this is the full Huffman coding calculation. Do you want to see it again? I think
Yes.
once more I
Yes,
think
sir.
once more you see this,
Yes, sir.
but this time I will not touch. Okay? Just you see. Okay. I think this method is also good. You can buy this, learn it better. I don't know, with some person who solve it with pen and pencil, uh, because we are in online mode. I cannot teach you on the board. I think maybe it will be helpful. Was this method okay or no?
Yes, okay, sir.
Okay. Please now you see once more. Maybe I will share this video also for you to again you do the steps with this person and enjoy. See, first of all, it has the probability and sorting the probabilities in the decreasing order. First, lower probabilities will be at B. I will not talk, sorry. This step is very nice. I think very simple and right for means that forward straight. He said very nicely. See how he will she calculate. Just pass the previous value to previous one. See, because point two was related to below one. Just put the previous value there. See, point two is result of these two. We just pass the value there. See, simple. And point two is from here, and another point two has the 1 0 code, and the other one has point four is the value of one. Now the steps that we should follow is that the length that should calculate. Then when we calculate the length, it's become 2.2. Next step is calculation for the entropy. We know this formula. Pi is the probability that you had, and log 2 of 1 divided by, again, probability that you had. Just simple, you will do probability multiplied by log 2 of 1 divided the probability for all the symbols that you have. Now you calculate, it's become 2121. Next step is having or calculating the efficiency. If you divide entropy by Li, it's come out. You will see that the calculation becomes 0.96. Next step is redundancy. We know it as the gamma. 1 minus eta will come. 1 minus this value, it's become okay. That was the calculating of Huffman coding with pen and pencil methods. I will try to give you this video that you can also again do the calculation, or maybe for exam, for your final exam, we have something like this to calculate. Okay, then be ready for this part. Okay. The next method for the coding is the arithmetic or range coding. People somehow they call it addresses coding redundancy. You know, Huffman coding encodes the source of symbols one at a time. Something that we see, everything will come at one time, which might not be, this method will be efficient. Arithmetic coding encodes the sequence of source symbols to some variable length code word. In this method, there is no one-to-one correspondence between the source symbols and code words, and it's slower than Huffman coding, but can be achieved better compression. One thing that I want you to I want you to remember or keep it in your mind means that these methods that now we are talking, all of them are statistical ones that and mathematical, mainly full for the full for the statistical one. They need some probability for that also to calculate. Remember this; these are the statistical method, Hoffman and these arithmetic coding. Then how we should do with this coding is like this. The main idea is that we should map a sequence of symbols to the number or arithmetic code in the interval of 0 and 1. Then encoding the arithmetic code is more efficient. We have some sequence of S1, S2, S3, S4, and so on, which we can rely on alpha 1, 2, 3, 4, 2, 3, 2, 4, and we want to map them or something like normalize them between 0 and 1. Each possible sequence will get maps to some unique number in domain of 0 to 1, okay, but not exactly 1, very near to 1, as you can see. In this method, the mapping depends on the probabilities of the symbol, and the mapping is built as each symbol arrives. Let us continue this method. You see that the main idea is something like that. We have the parameters of the alpha 1 to alpha 4, and we will start within the interval of 0 and 1, as you will see. See the next step. The sub-interval of 0 and 1 is chosen to represent the first symbol based on its probability of occurrence, and yes, we will select something between 0 and 1. As more symbols are encoded, the sub-interval gets smaller and smaller, and at the end, the symbol sequence is encoded by number within the final interval. Okay, means that the finally our symbols will be encoded within some interval between 0 and 1. Uh, okay. For this also, I bring one video for you that you can see. Suppose in this arithmetic coding, I want to encode the word which have the symbol of INDA, something like India, and I want to calculate based on this method. Let us see. The message is something like India, we have the symbol INDA, and based on the rule, we should not repeat the word of the I again. Means that what we should calculate, we should calculate each parameters or each symbols, let us say symbols, from the message once. If the word is repeated, you should not repeat it again. Then you have 4 and 5 parameter. Then if you want to calculate, first you should remember that how many parameter you have, how many symbol you have 5. But how many you should calculate? You should calculate 4 because 1 is repeated. Then after that, you just take the probability by dividing the number of the symbol to the total numbers. Here I have 5 symbol, and how many times it's repeated, I will divide. Suppose 2 times I have I, then I will take the probability of 2 divided by 5. For n, 1 time 1 divided by 5. For d, 1 time 1 divided by 5. A, 1 time 1 divided by 5. And calculation will come like 0.4, 0.2, 0.2, 0.2, 0.2. Okay, this is the first step to do with this algorithm. 2 by 5, 1 by 5, and 1 by 5. And this is the probability that is calculated. Then next is calculating the CDF. CDF is something like that. First, we will put the 0.4 as it is. Then we will add 0.4 to 0.2, which become 0.6. Again, 0.6 plus 0.2, which become 0.8. 0.8 plus 0.2, which become 1. The CDF will be calculated with these steps. Now, what we will do based on the CDF, we will write and note it in front of the parameter symbols that you have. Suppose for the A, we calculate the CDF of 1, D, we calculate the CDF of 0.8, for N, we calculate the 0.6, for I, we calculate the 0.4, and below is the 1. Something like this. We put the range between them. If you see, the range between 0 to 0.4 is related to I, 0.4 to 0.6 is related to N, 0.6 to 0.8 is related to D, and 0.8 to 1 is related to A symbol. And we can write them in the form of graph, or and frequency will be also written there. Now, as you see, the first word is I, then we will start from the message part. We will start and put the I as the top with the probability that we have. Now we can draw some line with like this. I will come out 0.4, and 0 will remain here. And now we should calculate some formula of UL. UL is the upper limit which come out from the lower limit plus dp. Dp is the probability that we have. Now you will see that he calculated like this. The probability, yeah, probability multiplied by difference between upper and lower. Lower is 0. Lower and upper limit is 0.4 again, and probability is also 0.4. This calculation will come 0 plus 0.4 by 0.4. Okay. We then again for the upper side, we have difference again of 0.4 and 0.4. This is for n. And probability is 0.6. Then we can put it here. 0.24 will be the calculation. Then next word is D. That calculation is also will be 0.4 multiplied by 0.8, and it's become 0.32. Then second word will come N. Because the step for N is 0.16, we will put it at the lower, and upper is the value of that. You know the range. See the range of the N. Again, we will calculate. lower level plus difference multiplied by probability. Then we have the 0.16 plus 0.08 multiplied by zero point 0.4, and we can calculate now. Yeah. Then for the I, you can now calculate and put the value there. Yes. 0.192 is the calculation for this part. Again, we will continue for the lower limit, difference, and probability, and it's become 0.2, 0.8. And again, lower value, difference, and multiply by probability, it's become 2.224. Next word is in D. D again, the place is 0.28. We will bring it as lower, and upper we will put 0.224. We will put it like this, and then we calculate. Same formula will come out, and you can see again upper limit, lower limit, multiply together, and we can calculate. Again, we will start to do the words for I and DA like that, and it'll come out. And calculation is again same, but the value is changed, means that the formula is same. He shows the calculation 0.214144. Again, next step for the N, and for the D, 2208 is there. Okay. We had one more I that we should calculate it again, because the message was I, and then but the value is between 2208 by 214. Yes, you will see. And lower limit, we will keep it as the same. Okay. Again, same formula and calculation with the different lower limit and upper limit, as you will see. 0.208 plus 0.006 multiplied by zero point 0.4. That can be calculated as the limits that we have. The calculation become 0.2104 as the first step. Again, we can write the steps and calculate and see these values which come out. The values will come out from the formulas. We calculate I and DI in the A is remain. Let us see. Last letter is A. But where is the range? Range is between 0.8 and 1 as the original one. But now the lower value is 2128. We will put here as the lowest, and highest is 0.21. Yes, 14. Then it will be finished, and we do the arithmetic coding with some word. It can be India, it can be China, it can be Iran, it can be Bangladesh, it can be any word. Just we should know what is the process. Do you want to see this movie again? This clip again?
Yes. Yes.
Okay. This time again, I will not touch. You can again repeat this from the first. Just see, first word is India. He will calculate the probability as well as CFD of that. First is probability will be calculated. Then we will sort the probabilities that we have from the up to down with the words of I and DA. Actually, we will specify some domain to each symbol if you see. And this code is something like assigning the domain's value. Then between these, we should start to see the main message. I and DA, we sort it, and upper one we will put at top, and lower one we will put as the lowest place. C. See how it will calculate the upper and lower limits one. And for the word and, we will start to calculate upper limit, lower limit, multiply by the probability, formula is fixed, just the range of the numbers is changed. Then you will see the calculation again. Then the next word we should do for the D, lower limit is 0.208, upper limit is 224. This is now the new lower limit and new upper limit. And for the word T, it's calculate. And do the calculation that you can see. Then the next word is I, that should be calculate. Then the next is because we had one more I, we should not miss that symbol. Again, we should do it. And again, we'll calculate it. And now you will see that we will calculate it again with the upper limit and lower limit. Okay, the word I is calculate. The next value is A. A, just you should see the domain. Domain of A is from here at the lower till this one. This become as the lower. And upper is 0.214. And this is the arithmetic coding. Okay. Here again, with some example, but I thought that that movie is perfect because when somebody calculate with the calculator and hand, it will be more effective. You will see that we have the four symbol of A1, A2, A3, and A4 with the probability of 0.2, 0.2, 0.44, and initial sub interval. Between them, we have 00 to zero point 0.2, 0.2 to zero point 0.4, zero point 0.4 to zero point 0.8, and zero point 0.8 to 1. Now, we will go to calculate between each domain based on this. Suppose A1 is upper limit is 0.2, lower limit is 0, A2 lower limit and upper limit, A3 upper and down, and also for the A4, this is something that we can calculate like this. As you will see, the interval and the code means that any number within this uh, interval will come out between this code. And finite precision arithmetic might cause the problem due to transaction. Please remember this point. If we want to then know this 0.068 can be encoded by using some functions of some binary functions and then this is in 9-bit, but if I want to compare it with the Huffman code, it has 10 bits. Then 1 bit is already reduced and compressed, and fixed binary code is 5 multiplied by 8-bit symbols, means that 40 bits we have there if we want to calculate. Let us see again the steps that already we talked in the uh, clips that we have. Point uh, 572 is the upper one, as you will see here, as the decoded part that you can use for this method. I think that clip was perfect. Even there is no doubt that how that person solved it nice. That is why I didn't solve again, and we use it today for our lecture. Okay, I think for first step of today, it's okay. Two methods we review. We review for rest of the methods that we have, and again we have some clips and which make it more clear. I think that seeing these clips make this coding simple. It's not much more difficult for you. And even I think at the end of these parts for today, for this second lecture, part two, we will have some MATLAB coding. Also, we have Mala's, I think, presentation today. Mala, are you ready for today?
Yes, sir.
Okay, okay. Then be ready. After this, I will hand over the lecture to you. Let me just finish this part, and then her application is nice. Also, she worked in the way that we want. Okay. The next method is LZW coding, which is address the interpixel redundancy. In this method, you require no prior knowledge of symbol probabilities, and you will assign the sequence of source symbols to some fixed length of code words. In this method, there is uh, no one-to-one correspondence between the source symbols and the codes, and uh, maybe it's interesting for you that in this method you have the output of GIF, TIFF, and PDF file format. Maybe you didn't know till today that when you convert your image to this TIFF or GIF or PDF, you are using this method. Let us see what is this compression methods. Little bit even fast. Yes. What we need in this method, we need the dictionary or code book to be constructed. And initially, first 256 entries of dictionaries are assigned to the gray level between 0 to 255. If we assuming that we have 8-bit pixel pictures, then as encoder examines the image pixel gray level sequence, for example, some blocks, there are not in the dictionary are assigned to the some new entry. We have suppose some example as you will see here 3939 126 126 126 126 like that as the matrix as I showed here. First we will check is 39 is in the dictionary? Yes. Then what about 39, 39? No. 39? No. Then we will add 39 minus 39 at the location of 256. Means that the value that we have, we will put it between value of 0 to 255. The new value will come after this, uh, what we can say, after these steps. I think maybe if again we will see one clip, it will be more clear for you that how you work. Uh, Suppose here we have the sequence between, as I shown here, 3, 1, 4, 6, up to 6, an initial dictionary that it give us means that the initial dictionary is, let me, she's talking more actually. Some initial dictionary we have with the index and entry. Okay, we have index of 1, which is related to A, 2 to the B, 3 is related to R, and 4, which is related to the T. We are going now to calculate this. Okay. First, we will start in this decoding. We will build the dictionary. Again, we will write the dictionary at the index and entry. In this method, we will update the dictionary and we will also see the sequence and go on with this. See. Dictionary 1, index 3, and index 4, which is entry to A, B blink, and R and T. If we want to write the sequence, first is 3. We have the index, yes, that was R. That is 1. 1 is equal to A. We will do 4. 4 is equal to T. 6 is not there. We can add. What we should do? Up to here, we had in the dictionary at the rat, but for the 6, we don't have. What we should do? Then we should add this to our dictionary. The rat message is come already with the data that we have, but for the 6 one, we didn't have. Okay. Then we will make the RA as the dictionary for the 5. And then we will see that how we should select this. We should take the last iteration, I mean, last simple and the 1. Then 80 is there. And 6 will become 80. Now we will see again. We have 6. 6 is equal to 80. We will add it. Then next is 8. 314 will give RAT, and then 6 we generate as the 80. Again, we fall on the same problem. We don't have the 8. 8. What we should do? We should generate again. How we should do? We have the last value of 80. This is a good question because with that you can see how you will how you should generate the coding with this LZW. Okay. Now for the 8, what we should do? We should see the last 2 words that we had. But before 8, we should generate the 7 for that. See, we have the entry for the RA and 80. And you will see that the next entry is TA. Then TA can be as the 7. Okay. And then what about 8? Next iteration should be A. But T we cannot take because T we had before for the 6. Then T should not come. We can take something else. Then AT with something should add. Then what we should do? Here we don't know exactly what should come for the 8, but it should start with 80 and some added things to this. Let us see. 80 and something there, some blank things. That blank should be there. Then we will write 80 and blank. Then maybe A will be the better things because I had AT, but I didn't. Then it's written my name, ATA. Yeah. Okay. Then A we will put there. Then we go for the 4. Okay. 4 we have in dictionary. It's T. We can put. With the 14 text we have T. 2 we have B blank. We will put. For the 1 we have A. We can put. For 2 we have B blank. For 5 again we have RA. We can put. Now 10 again. Again, we don't have 10 inside our dictionary. What we should do? We should stop and update the dictionary. But first, we should generate 9 and then we should go for 10. We were up to 80A. Again, something we have. And 80 we had for the 6. And again, 80A we had again for the 8. Then we cannot use 80AT. Let us see. Yes, can be ATAT. And 10. For 10, we have AT, maybe B blank. Or TB blank we don't have. We will put TB blank there as the 10. Update. Okay. As we know, up to 13, there is the maximum index. Then we should generate it. Let us do it first and then continue. Next stage where B blank A that we can do. B blank A, we will put for alone. Next is AB blank. We don't have, then we will make it AB blank. Then 13. Then B blank or maybe the next one that we can. Yes. B blank or is the next one. Then dictionary is updated. Now we can continue the sequence easily here. Yes. 10 we have TB blank. 6 we had 80. 11 we had B blank A. 13 we have B blank R. For 6 we had AT. Then this LZW decoding done very simply, just with this. Main thing that you should be aware about it, you should update them simultaneously. Then just update dictionary as well as the numbers that you had at the top. Then otherwise, this is simple and you can follow it. Okay. Do you want to again repeat the video for you? Do you want to see it once more? answer?
No, sir, it's okay.
Yes,
It's
sir.
okay? Yes or okay? See it once more. Whole example is something like that. I will go little bit fast. First, we will make the dictionary, the numbers that we have. 1, 2, 3, 4. The value we have A, B blank, R, and T. And if you can see, we don't have 5, we don't have 7. These are some sequence that we should generate. Okay. Okay. 3 number we had. 3 was the R. We can put it there. I think this time I will not talk, just you see what he said. See, the numbers was there up to 6. Then for the 6, she start to generate the new dictionary again because that value is not there. But how we should do? We should start from first two character, which is RA, and for the 6, second two, which is AT. Again, we will select that T. See this 6. Okay. Now what we have? We have AT. Okay. We can generate that 80, and now we can continue. But again, we don't have 7 and 8. Again, we should generate. How we should do? We can go for next two. Next two is TA, which we can put for 7. See, 7. Okay. See again for the 7, what she will do? We have RA, we have AT, we have TA. Okay. TA can be generated by 7. Again, next is 80, but 80 we cannot do because we had before. 80 is assigned for the index of 6. Then what we should do for the 8? We know that we have 80 and something. That is why we put it blank. Hmm. Now we can put again 80 there. Then we will put 88. Okay, then we have 88 for 8. We can continue. 4 and 2 we have, and 1. Okay. 5 we had, we can put 10. 10 we don't have. Again, you should generate. And now you will see that again we can generate 88T and TB blank. And for 11, again we can continue. AB blank can be there. BA, B blank A, yes. As we don't have in dictionary, we can add. Then AB blank. No, we can put there. B blank R is also is not there. We can put and finish. Then we can just again assign the index to the dictionary that we had. Let us see. Yes. Just note down the message. And this sequence is finished. You can do it. Okay. That's okay for that LZW. I have one more clip that I think I will share with you, and you can see it because we should considering the time also. Malad should also speak today for us. Let us continue for the more about this LZW. As you will see here, for the previous example that I show you, we have the matrix of 39, 39, and 126. And then with that, we have the pixel bending, and then which we can again find it in the dictionary that we have any number which we don't have, we can generate a new dictionary and then do the calculation and do the coding based on that numbers. I think that movie was proper and good. And further, more example can be with the video that I will share for you. This decoding LZW can be done just to using the dictionary again, and no need to transmit the dictionary for decoding. It can be built on fly by decoder as it reads the received code words. Means that this dictionary also will be go along the code. And that was also one method. The next method that we will learn is RLC, or run length coding, which in that we are going to reduce the size of the repeating string of simple, for example, runs. We have some example, something like the binary as it's shown here, and some words which encodes a run of the symbols into 2 bytes, symbols as well as counts, and can compress any type of data, but cannot achieve the high compression ratio compared to the other comparison methods. In this, in this RLC also, uh, we will compress the word. But before that, let us see one more methods that people will do. They combining the Huffman coding with run LCD and assuming that the message has encoding using the Huffman coding. Additional compress also we can have. Means that remember that some method like this, which is the mixture of two or three, also can be achieved with this type of the data. Let us see what is RLC in these clips, and then yes, we have bit plan also. Two more method we had for today that we should review. Okay. Then run let's coding for these codes. Suppose assume this string that I have. We have 5 times for the 0, 0, 1, 1, 1, 1, 1. Again, 5 times for these 0, 0, 1, 0, 0, 0, 0, 1, 0, 1. First thing is that we should count how many zeros suppose I have. I have 5 0 here to the similar value. 5 1 2 2 continuous term, just we will calculate. We have 1 1. Again, continuous 0 is 4, 1 1, 1 0, and 1 1 that we have. In the second step, what I should do, I should know that 0 and 5, 5 times, 1 how many times? 5 times, 0 2 times, again 1 1 times, 0 4 times, 1 1 times, 0 1 times, and again 1 1 time. Now we will count the term 1 2 3 4 5 6 7 and 8. The third step for this calculation is that after sorting, counting, is that we should calculate the formula of log 8. Because we have 8 sequence, we should calculate the log 8 by 2, by base of the 2. As you know, log 8 can be 2 rises by 3. It can be log 2 by 2, which it's called by 3. Then we have the 3 bits for all that you can compromise them. Next is that you should calculate 0 and 5 as the bits of 101. Again, 1 as 5 is 101 in binary coding. 0 in binary coding is 10. 2 is 10. 0 1 0, sorry. Yes. And 1 is again 1 and 0 0 1 that you can write. 4 is equal to uh, 0 1 1. Come 3, it's become 1 0 0. Yes. Next one is 1 and 1, which is equal to 1 and 0 1 0. Yes. Again, 0 and 0, 0, 1, and 1, 1 is 1 and 0, 0, 1. As you will see, I change it now to the binary. The final things that we can do, final code, we can write them all in one line like this. 3, 0, and then the value 1, 0, 1, 10. 1, 1, 0, 1, again 0, 0, 1, 0, 1, 0, 0, 1, again 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1. This is the final code that generate with the method of RLC, or address interpixel redundancy. And you will see the main string that we have, and this is the coded with this part. Okay. The next coding method that we have, this is the bit plan, which is address the interpixel redundancy. And in that, we will process each bit plan individually. We decompose an image into some series of binary image and compress each binary image, for example, using roundlet coding. As you will see, we have bit plan of 8, most significant, and bit plan 1, which is the least significant. And let us see how suppose we will do this bit plan 1 in the MATLAB. Here, for this, because we have the least time, what I will do, I have done that example, and again, I will repeat for you. Uh, you can watch this video because that video information was also nice. Based on that, I again code and do this coding that you can understand this part better and watch the, what we can say, coding of him better. Let us, yes, I should share my desktop with you. Just hold on that I run my MATLAB, and then we will see how this coding is work. I will try to put the videos on the MOOC. Uh, I should see that how much Roy will help me today, that I can do it today or maximum by tomorrow. But surely I will do that. You will also enjoy. I think today was a little bit better because uh, we could see with paper and hand, and I saw that to save the time I'm preparing this PPT for you. Maybe this method that today I use will be more useful for you. Okay, let me see. I should share my desktop. Can you please see the MATLAB's environment? Yes. Yes. Can you see now?
Yes, sir.
Yes, sir. Now it's
Okay. This bit plan, as you see, it's something like splitting and putting the sheets on the. Maybe some of you say that we just doing some mathematical part. It's not on the image, but really all of them are on the image. First of all, second thing is that I should notice for you is that this method, it's mathematical, but as we know the image in the form of matrix, there is no difference between them. Means that there is no difference that you do with the matrix or you do with the form of um, just pure mathematical things. Both of them have the same view for us. We don't know the image We just know the matrix of number. Okay, then everything will be solved. Okay, what we have done, we are opening the paper PNG format. Let me do the IM show for A and put this as suppose figure 100. That is something that I forget to show meanwhile of my code. Yes. Now let me add this inside my code. I am show A. Then maybe it will be more clear. What we are okay. Nice. I put the figure. In this method, it's going something like splitting and putting the sheets on my. This is my original image. As we said, for this lossy one, the first step is that it will converting into the grayscale one, but already the image that we have is the in the gray form. Okay. The problem is here that I should put here 2 and here. Okay. Now it will solve and you can see the answer. Yes. This is the original one, but now we can see the sheet by sheet on the image. LSB bit plan is something like this. Let me make it a little bit bigger that maybe you will enjoy more. Yes. Oh, and this is the original one. Let me make it small for you. Yes. See the LSB bit and MSB bit of the bit plan decoding. What it will do, it's going to compress it, but you will see that here some data is lost. I don't say that what is the use of them. You will see on the next lecture about JPEG image and how they will generate the JPEG image. But here you will see that sheet by sheet, it's going to split the image. And if you put all sheet together, you have the first image that we had before. That was just the rough idea that for the bit plan we will put more detail by the MATLAB I put for the video that you can read it yourself. Had one Huffman coding also example that let me show that also for you, or maybe I will do next lecture for you.